Rolling is quite a common phenomena that we see around us. So we see it, for example, a ball, it rolls over a surface, or if you put this ball on an inclined plane, at rest it will start rolling down the plane. There are the wheels, and there are many different kinds of rolling motion. Now, the rolling motion we will study in two different groups. One of them will be rolling without slipping. For example, this motion is rolling without slipping. Another motion will be that we will study will be rolling with slipping. So, for example, if I hold this ball and rotate it, in this case the ball is rolling, but the surfaces touching each other over here, the surface of this table and the ball, they are slipping over each other. So, of course, this can be also combined with some translational motion. So, in particular, if I start rotating the ball and release it from rest, it will first roll with slipping and then it will accelerate forward. So all these kinds of motion we will study. So let's start with rolling without slipping. Now if we study this rolling without slipping in some detail, so this is the surface over which the ball is rolling. Here is the ball. The ball is moving, let's say, with some velocity v in this direction. Now let's go to a different reference frame. So let's go to the reference frame which is moving with the velocity v. And that is essentially we are moving with the ball at the same speed, in the same direction. Now in this reference frame, this is what we will see. The ball has a fixed rotational axis. It is rotating in the, if the ball is moving in this sense, the ball is rotating clockwise. The ground is moving backwards with a velocity of minus v. Since we are moving with the ball, the surface that the ball rests is moving backwards with a velocity given by minus v. Note that if the ball is not slipping, then this point over here, the point of the ball that touches the surface and the surface, it just means that they are moving with the same velocity. So this point on the ball is actually moving with the speed v. But if this radius is r, so v should be equal to omega times r. Note that this relation holds for every point on the surface of the sphere, whether of the ball, let's say, whether the ball is slipping or not. This relation is always true if v is the speed of the point on the ball. But here v is the speed of the floor, not of the ball. So if the ball is not slipping, then this point where the surface touches the ball, the point on the ball that touches the surface has exactly the same speed as the surface. So this v being the speed of the surface is equal to omega times r only if the ball is rolling without slipping. So this relation, this relation we derived in this reference frame, but it also holds in this reference frame. So if the ball is rolling without slipping, then the speed of the linear speed of the ball will be equal to the angular velocity of the ball around its center of mass, or in fact around any axis, times the radius of the ball. This is the condition for rolling without slipping.